Before time had a name, before space had a shape, there was nothing. No light, no darkness, no past, no future, just an infinite void, silent and still. And then, in an instant, everything changed. This is the story of the universe, the grandest tale ever told. A tale written not in words, but in the very fabric of reality itself. A tale of fire and ice, of birth and death, of chaos and order. It begins in a singular moment, a moment so brief that human minds struggle to comprehend it. The Big Bang. The Big Bang was not an explosion in space. It was the sudden expansion of space itself, a cosmic eruption from a point of unimaginable density and temperature. In less than a trillionth of a second, the universe expanded from smaller than an atom to the size of a galaxy. Matter and energy roared into existence, governed by the fundamental forces that would shape everything that was to come. At first, there was only energy, searing, incomprehensible energy, hotter than a billion suns. But as space expanded, it cooled. And with that cooling came change. Energy condensed into particles, the very first building blocks of reality. Protons, neutrons, and electrons danced through the fiery plasma of the newborn cosmos, colliding and combining in a chaotic, swirling sea. The universe was less than a second old. At this stage, it was an ocean of light and heat, a place where particles and antiparticles annihilated one another in a relentless battle for existence. But by sheer chance, perhaps a deep, fundamental asymmetry woven into the laws of physics, more matter survived than antimatter. This tiny imbalance, just one part in a billion, ensured that something, rather than nothing, would form. That galaxies, stars, and planets would one day exist. That we would exist. As the seconds stretched into minutes, nuclear forces began their work. The simplest atomic nuclei were forged in a process known as primordial nucleosynthesis. Hydrogen and helium, the most basic elements in the universe, were born in this fiery crucible. These elements would become the raw materials from which all future structures would emerge. But even now, the universe was far from the place we know today. It was a blinding, opaque inferno of energy and radiation, a cosmic soup where photons, the particles of light, were trapped, unable to travel freely. The universe was still a child, and it would be hundreds of thousands of years before it took its next great step. At around 380,000 years after the Big Bang, a monumental transformation occurred. For the first time, the universe became transparent. As it expanded and cooled further, electrons found themselves drawn into the embrace of atomic nuclei, forming stable atoms. This event, known as recombination, allowed light to finally break free, traveling across space without obstruction. The cosmos, once an opaque fog, became vast and open. This light, the first free light of the universe, still exists today. It has been stretched by billions of years of cosmic expansion, becoming the faint glow we now call the cosmic microwave background. A whisper from the dawn of time, carrying within it the imprints of the first moments of existence. And yet, at this point, the universe was still dark. Though light could travel, there were no stars to shine, no galaxies to scatter their brilliance across the cosmos. For millions of years, the universe was a dark, empty void, waiting for something more. These were the cosmic dark ages, but hidden within that darkness, something extraordinary was beginning. Gravity, the silent architect of the cosmos, was at work. Tiny imperfections in the distribution of matter, left over from the Big Bang, became seeds of creation. Under the pull of gravity, vast clouds of gas began to collapse, gathering into denser and denser regions. Over millions of years, these pockets of hydrogen and helium grew hotter, denser, more extreme. And then in the depths of darkness, the first stars were born. These first stars, known as population 3 stars, were unlike anything that exists today. They were giants, hundreds of times the mass of our sun, burning with an intensity that is difficult to fathom. They were the first beacons in the cosmic night, transforming the darkness with their brilliance. But they were also short-lived. Within just a few million years, they burned through their nuclear fuel and met spectacular ends as supernovae scattering the elements of creation across space. These stellar explosions were not mere endings, they were beginnings. For the first time, heavier elements, carbon, oxygen, iron, were forged in the hearts of dying stars and cast out into the cosmos. These elements, the fundamental ingredients of planets, of life, of us, would go on to shape the future in ways unimaginable. With each generation of stars, the universe became richer, more complex. Clouds of gas coalesced into galaxies, vast collections of stars bound together by gravity. The earliest galaxies were small, chaotic places, constantly merging and reshaping as they danced through the vastness of space. Over time, they grew into the grand spirals and elliptical giants we see today. Among them, one small, unassuming galaxy was beginning to form, a galaxy that, billions of years later, would come to be known as the Milky Way. And so the universe was no longer a dark, empty place. It had become a cosmic tapestry of light and structure, a grand, ever-evolving work of art. But this was only the beginning. The story of the universe was still young, and the forces that shaped it were far from finished. As the cosmos continued its silent expansion, the fire and fury of the Big Bang gave way to the quiet ballet of creation. In the vast stretches of space, gravity, the invisible hand that sculpts the universe, began its patient work. Matter, once a chaotic sea of particles, started to gather. Clumps formed, drawn together by their mutual attraction, slowly weaving the fabric of the first galaxies. For hundreds of millions of years, the universe remained shrouded in darkness. It was a time of quiet potential, a cosmic dawn waiting to break. The vast clouds of hydrogen and helium that had emerged from the fire of the Big Bang lay thick and unmoving. Yet within them, the seeds of stars were taking shape. Tiny fluctuations in density, remnants of the primordial chaos, gave gravity a foothold. Where there was just a little more mass, attraction strengthened. Gas clouds collapsed inward, their centers growing hotter and denser, until finally, after millions of years of silent preparation, the first stars ignited. These were not like the stars we see today. The first stars, called Population 3 stars, were giants, enormous and unstable, burning with an intensity we can scarcely imagine. They lived fast and died young, blazing for mere millions of years before collapsing into violent supernovae. But in their brief lives, they performed a task of incredible importance. They forged the first heavy elements: carbon, oxygen, nitrogen, ingredients essential for life, were cast into the universe for the first time. The cosmos, once composed of only hydrogen and helium, had begun its slow transformation into the complex and vibrant place we know today. As more stars were born and more supernovae erupted, the universe changed. The light from these early stars did something remarkable. It reionized the hydrogen that had once darkened the cosmos. Before this, the universe was cloaked in a fog that prevented light from traveling far. But as starlight spread, it tore apart these hydrogen atoms, making space transparent for the first time. The great cosmic night had ended. The first sunrise of the universe had begun. With this newfound clarity, galaxies took shape. The first structures in the cosmos were small, proto-galaxies merging and clashing in the dance of cosmic evolution. Over time, through the slow but relentless pull of gravity, these small galaxies combined, forming larger structures, galaxies like our own Milky Way. This process was violent, collisions stretching across millions of years, creating swirling patterns of stars and gas, birthing new generations of suns. Yet not everything in the universe was visible. There was something else at work, something unseen but essential. Dark matter, an elusive, invisible substance, exerted its influence. Though it neither emitted nor absorbed light, its gravity shaped the cosmos. Like scaffolding holding up the night sky, it provided the framework upon which galaxies formed. Without it, the universe would look very different. Even now, we do not fully understand dark matter, but its effects are undeniable. It binds galaxies together, preventing them from tearing apart as they spin through the void. At the heart of many young galaxies, another enigma stirred: black holes. Born from the deaths of massive stars, these singularities of gravity consumed matter with an insatiable hunger. Some grew to enormous proportions, becoming supermassive black holes, millions, sometimes billions, of times the mass of our sun. These cosmic titans shaped the evolution of their galaxies, their immense gravitational influence directing the formation of stars and the movement of gas across millions of light years. The universe, once a featureless expanse, had grown structured, rich, and complex. Galaxies stretched into vast clusters, connected by delicate threads of cosmic filaments, great rivers of matter spanning the depths of space. The earliest epochs of chaos had given way to an ordered grandeur, where light and shadow wove together the tapestry of the cosmos. And within these galaxies, something extraordinary was beginning to unfold. Among the countless stars in the quiet corners of space, planets were forming. Swirling disks of dust and gas surrounded young stars, coalescing into worlds of all kinds. Some were barren, lifeless rocks. Others were gas giants, their thick atmospheres swirling in alien tempests. But among them, here and there, were planets where conditions were just right, where water could flow, where chemistry could begin its delicate, intricate dance. The foundations for something truly rare were being laid, the possibility of life. The journey from the primordial void to the formation of galaxies had been long and complex, spanning hundreds of millions of years. But in the vast and quiet reaches of space, a new story was beginning, one that would shape the cosmos in ways yet unknown. As the universe continued its endless expansion, as galaxies drifted and stars burned, the next chapter of existence was waiting to be written. A chapter where, among the vastness of the cosmos, the miracle of life would take its first tentative steps. As the universe matured, the cosmic ballet took on a new, intricate form. From the swirling clouds of gas and dust, something extraordinary began to emerge. Planets. These celestial bodies, bound in an eternal waltz with their parent stars, would become the settings for the next great act in the story of existence. The process of planetary formation was one of patience and persistence. In the protoplanetary disks that circled young stars, tiny grains of dust collided and clumped together, gradually growing larger. Gravity, ever the sculptor, encouraged these fledgling worlds, drawing them into orbits and dictating their fates. Some of these nascent planets, close to their stars, were scorched by radiation, their surfaces molten and hostile. Others, further away, grew to immense sizes, their thick atmospheres trapping swirling storms of gas. And then there were those lucky few, planets that found themselves in a delicate balance, neither too close nor too far from their stars, where conditions might one day allow for something truly miraculous. Life. The birth of planets was a violent affair. Collisions were common, with protoplanets smashing into each other in a chaotic struggle for dominance. Some worlds were obliterated entirely, their remains scattered across space, destined to be recycled into new celestial formations. Others survived these cosmic trials, forming into rocky spheres, gas giants, or ice-covered enigmas drifting in the cold outskirts of solar systems. In our own cosmic neighborhood, this process played out over millions of years. The young sun, still settling into its mature state, was surrounded by a disk of debris. Over time, these fragments coalesced, merging into the planets we know today. Earth, Mars, Venus, and Mercury formed from the rocky material close to the sun, while Jupiter and Saturn grew from vast amounts of gas further out. Beyond them, Uranus and Neptune emerged, their compositions rich with ices and volatile compounds. Yet even after their formation, these worlds were far from peaceful. The early solar system was a place of immense upheaval. Rogue asteroids and comets bombarded the planets in a period known as the Late Heavy Bombardment, shaping their surfaces and, in some cases, bringing essential ingredients for life. These cosmic wanderers, rich in water ice and organic molecules, may have delivered the first seeds of biology to young, barren worlds. Earth, in particular, was a world of extremes. Volcanic eruptions spewed gases into the atmosphere, shaping the air that would one day sustain life. Oceans of molten rock cooled to form solid land. And above it all, the moon, our constant companion, was born from a cataclysmic collision between Earth and a Mars-sized body named Theia. This event, violent and dramatic, left a lasting mark, with the moon stabilizing Earth's tilt and influencing its climate. Meanwhile, on distant worlds, different stories unfolded. Venus, once perhaps similar to Earth, suffered a runaway greenhouse effect, turning into a hellish landscape of scorching heat and crushing pressure. Mars, losing its atmosphere to the harshest solar wind, became a barren desert, its once flowing rivers now only scars upon its rust-colored surface. And yet, in their pasts, both may have been home to liquid water, a tantalizing hint that life might not be unique to Earth. Beyond our solar system, planets were forming in countless other star systems. Some of these worlds, orbiting in the habitable zones of their stars, held the potential for conditions similar to our own. With each new discovery, astronomers glimpsed the possibilities of other Earth-like planets, places where life, in some form, might exist. Could alien oceans harbor strange creatures beneath icy shells? Could distant atmospheres swirl with clouds that rain something other than water? As the eons passed, the universe continued its slow but relentless march forward. The planets that survived the chaotic early days found stability in their orbits, locked into rhythmic dances dictated by gravity. Some, like Jupiter, became guardians, their immense gravities deflecting comets and asteroids away from the inner solar system. Others, like Saturn, adorned themselves with breathtaking rings, remnants of shattered moons or leftover debris from their formation. And then, on at least one world, something remarkable began to stir. The chemical elements, forged in the hearts of ancient stars and scattered across space, found their way into pools of liquid water. Here, under the right conditions, a new chapter in the universe's story was beginning, the story of life. But that is a tale for another time. As the vast clouds of gas and dust swirled through the young galaxies, some found themselves drawn together by the silent force of gravity. Over millions of years, these clouds thickened, colliding and merging in a slow cosmic ballet. From this dance, something new emerged: worlds. The birth of a planet is an act of violence and patience. It begins in a protoplanetary disk, a swirling ring of dust and gas surrounding a newborn star. Within these spinning rings, tiny particles drift and collide, sticking together like flecks of dust in the breeze. They form pebbles, then rocks, then boulders, all clumping into larger and larger bodies, drawn together by the unseen pull of gravity. Some of these bodies would grow large enough to become planets. Others, too small, would remain as asteroids and comets, cosmic wanderers that would one day carry the echoes of these ancient times across the solar system. As a young planet takes shape, its surface is a seething, molten landscape. Collisions are constant. Some are small, barely noticed in the great expanse of time. Others reshape entire worlds. One such collision, billions of years ago, changed the fate of our own Earth forever. A Mars-sized body, now lost to history, struck the young Earth with unimaginable force. The impact sent a vast plume of molten rock and debris hurtling into space. Over time, this debris coalesced, forming the glowing sphere that would become our moon, a silent companion, locked in an eternal waltz around our planet. But Earth was not alone in its story. Across the cosmos, planets and moons were forming in myriad ways. Some, like Jupiter, would grow into gas giants, their thick atmospheres hiding cores of unknown nature. Others, like Mars, would form from rock and dust, their fates shaped by water, wind, and time. Water, it is the key to life, and its journey through the cosmos is as mysterious as the universe itself. On some planets, water arrived in the form of icy comets, bombarding the surface over millions of years, delivering the building blocks of oceans. On others, it was locked within the planet's very crust, seeping out over eons to carve rivers, lakes, and seas. Not all worlds were so lucky. Some, like Venus, became suffocated by their own atmospheres, their surfaces transformed into searing wastelands. Others, like Mercury, were stripped bare by the relentless energy of their star, leaving behind only airless, rocky husks. And then there were the rogue planets, worlds cast adrift, ejected from their solar systems by the chaotic gravitational battles of formation. They wander the void alone, their surfaces frozen beneath eternal darkness, drifting endlessly through interstellar space. But on some worlds, in the right conditions, something remarkable began to happen. Deep in the swirling oceans, in the cracks of underwater volcanoes, or perhaps in the still pools of ancient lakes, complex molecules formed. These molecules would set in motion a chain reaction that would lead to something the universe had never seen before: life. For billions of years, the universe had been a stage for titanic cosmic events: galaxies colliding, stars being born and dying, planets forming in the chaos of creation. But now something far more delicate was stirring. A transformation was beginning on at least one small, rocky world bathed in the light of an ordinary star. A transformation that would take matter, once nothing more than lifeless dust and gas, and turn it into something new. Something that could move, adapt, and one day even think. Life. But where did it begin? In the shallows of warm, primordial seas, where energy from the sun helped catalyze reactions? Or perhaps in the lightless depths of the ocean, near hydrothermal vents where heated minerals bubbled from the planet's interior? Maybe it began in tide pools where water evaporated in cycles, concentrating organic molecules until something unexpected occurred. Wherever it began, the process was slow, so slow that if we could watch it unfold in real time, it might seem as though nothing was happening at all. But deep in the microscopic world of organic chemistry, carbon-based molecules were forming complex chains, twisting into shapes that could interact with their environment. Some structures became more stable than others, capable of making crude copies of themselves. Imperfect copies, but copies nonetheless. And from those imperfections, mutation. These self-replicating molecules, perhaps the ancestors of modern RNA and DNA, formed the foundation of all life. Over millions of years, they became encased in protective membranes, forming the first true cells. These primitive organisms were nothing like the vast ecosystems we know today. They were simple, microscopic, barely more than tiny chemical factories drifting through an alien ocean. But they had something no other matter in the universe had achieved: the ability to change, to evolve. And evolution is relentless. Driven by the silent forces of mutation and natural selection, life diversified. Single-celled organisms developed new ways to survive, some feeding on simple chemical compounds, others harnessing the power of sunlight through photosynthesis. Over time, this new process transformed the planet itself. These tiny life forms pumped oxygen into the atmosphere, altering Earth's chemistry forever. At first, it was a catastrophe for many of the early anaerobic organisms that thrived in an oxygen-poor world. But for others, it was an opportunity. With oxygen came the potential for greater energy production. Life became more complex. Some cells engulfed others, forming symbiotic relationships that led to the first eukaryotic cells, the kind of cells that would one day build plants, animals, and even us. For hundreds of millions of years, life remained microscopic, an unseen revolution happening in the depths of the oceans. But then something astonishing occurred. Cells began organizing into larger structures, forming the first multicellular organisms. The age of the microscopic was ending. The age of the visible was about to begin. The first multicellular life forms were simple at first: colonies of cells working together, each specializing in different tasks. But as the eons passed, evolution sculpted these organisms into increasingly complex forms. Soft-bodied creatures slithered and pulsed through ancient seas. Strange alien forms dominated the ocean floors: filter feeders, primitive jellyfish, and bizarre organisms that defy classification even today. Then, in what may have been one of the most dramatic bursts of evolution in Earth's history, life exploded into diversity. This event, known as the Cambrian explosion, saw the sudden emergence of an astonishing variety of creatures, some with armor-like shells, some with eyes for seeing, some with grasping limbs to hunt and devour others. Predation had arrived, and with it, the arms race of evolution had begun. Life was no longer just drifting, it was competing, adapting, struggling to survive. The oceans became an ecosystem of endless interaction, predator and prey locked in an evolutionary dance, that would shape the very structure of the living world. Some creatures ventured beyond the safety of water, their bodies adapting to survive on land. Simple plants, which had once floated in shallow waters, took root in the soil, spreading across the barren continents. Insects scuttled between them, the first true land animals. The conquest of land had begun. Over hundreds of millions of years, life would take on endless forms. Giant amphibians that ruled the swamps, towering ferns that shaded the first forests, reptiles that would evolve into the mightiest creatures Earth has ever known. But every step forward in evolution was accompanied by struggle. Mass extinctions reshaped the biosphere time and time again, wiping out entire branches of the evolutionary tree and leaving room for new life to take their place. From simple organic molecules to the thriving, competitive, and diverse ecosystems of Earth, the path of life had been anything but inevitable. And yet, here it was, a cosmic accident or a natural result of the laws of physics. Perhaps on some distant world, in the light of an alien sun, the same process was unfolding. Perhaps even now, new life was beginning somewhere else in the universe, waiting, growing, changing. As the cosmic clock continued to tick, the story of the universe took a dramatic turn. On one tiny world, circling an ordinary star in the outskirts of the Milky Way, something extraordinary was unfolding. Life, which had clung to this planet for billions of years, had taken a remarkable leap. Intelligence had arisen. For the first time in cosmic history, at least as far as we know, the universe had become aware of itself. It began with simple observations. Early humans looked to the sky and saw points of light moving across the heavens. The sun rose and set with unfailing regularity. The moon changed its shape in a predictable cycle. With each passing generation, the desire to understand deepened. Firelight flickered on the walls of caves as stories were told. Myths created to explain the motions of celestial bodies. But myths would not satisfy forever. Something fundamental had changed in the way these beings thought. Curiosity became an unstoppable force. These creatures, now calling themselves humans, built monuments to track the stars. They aligned great stones to the solstices and created calendars to measure the passage of time. Science was born. The first great civilizations, from Mesopotamia to Egypt, from China to the Americas, all sought to understand the universe in their own way. The Babylonians meticulously recorded planetary motions on clay tablets. The Greeks proposed that the Earth might be a sphere, and even calculated its size with remarkable accuracy. In India and the Islamic world, scholars preserved and expanded upon ancient knowledge, refining mathematics, physics, and astronomy. The great thinkers of history peered into the heavens and saw order in the chaos. They devised theories and tested them against the reality of the cosmos. The idea that the Earth was the center of everything began to crumble. Copernicus proposed that the sun, not the Earth, lay at the heart of our celestial dance. Galileo's telescope revealed mountains on the moon, moons around Jupiter, and countless stars beyond what the human eye could see. Newton's laws of motion and gravity described the forces that shaped not only the planets, but the very fabric of the cosmos itself. With each breakthrough, humanity's place in the universe shrank. The world was not the center. The sun was just another star. The Milky Way was merely one of billions of galaxies. But with each revelation, the awe deepened. By the 20th century, our curiosity had turned to ambition. For millennia, humans had gazed at the moon and dreamed of walking upon it. Now, rockets roared to life, piercing the sky, carrying our species beyond the boundaries of Earth. In 1969, for the first time, a human being stepped onto another world. That's one small step for man, one giant leap for mankind, echoed through the cosmos. The dream of space travel had become reality. The decades that followed saw robotic explorers journey to the planets. Probes sailed past Jupiter's swirling storms, landed on the barren soil of Mars, and danced through Saturn's rings. Telescopes, freed from the blurring veil of Earth's atmosphere, captured images of galaxies as they were billions of years ago. The secrets of the universe were being unraveled at an unprecedented pace. But with discovery came new mysteries. Dark matter, an invisible substance holding galaxies together, remained elusive. Dark energy, a force accelerating the expansion of the cosmos, defied explanation. The search for life beyond Earth became more urgent than ever. Could the cosmos be teeming with other minds, also searching for meaning? As we stand at the edge of the vast unknown, we are reminded of our fragility. The Earth is but a pale blue dot in an ocean of darkness. Our sun is one of hundreds of billions of stars, in a galaxy adrift in an incomprehensibly vast universe. And yet here we are, thinking, exploring, searching. The rise of intelligence is not just a scientific phenomenon, it is a profound cosmic event. For the first time, a species has looked back at the universe and asked, why? And the search for answers continues. The universe, ancient and vast, has unfolded in ways both expected and unforeseen. Billions of years have passed since the first stars flickered to life, since galaxies stretched their luminous arms across the void. Now we enter a chapter of the cosmos that is at once familiar and mysterious, an era defined by the emergence of intelligence, the growth of civilizations, and the profound questions that arise when life seeks to understand its own existence. The grand cosmic drama has already seen stars ignite, planets form, and the delicate balance of chemistry give rise to biology. But intelligence, this is something altogether different. Intelligence is the universe observing itself, questioning itself. It is the cosmic dust, assembled over eons, suddenly aware of its own history. And so, on a quiet planet orbiting an unremarkable star, something new was set into motion. Millions of years ago, the ancestors of humanity wandered the plains of Earth. Their minds, shaped by evolution, grew more complex. They learned to work together, to build tools, to harness fire. It was the first flicker of something extraordinary. A species that could pass knowledge through generations, that could imagine futures yet to come. And from these simple beginnings arose civilization. For most of its history, Earth was nothing more than a silent observer of the cosmos, an insignificant speck against the vastness of space. But with time, human beings began to shape their world in ways that no other species had done before. They constructed cities that pierced the sky, machines that conquered the land and sea, and ultimately, technology that allowed them to reach beyond their own atmosphere. The 20th and 21st centuries saw the first steps of a species attempting to leave its cradle. Rockets carried explorers beyond the pull of Earth's gravity. Machines roamed the surface of the Moon, and later Mars. Space telescopes peered deep into the distant past, unraveling the secrets of galaxies born billions of years ago. The human mind had begun to bridge the gap between knowledge and action, to transform understanding into exploration. Yet for all its achievements, humanity remains confined to a single world. The universe, it seems, is not eager to yield its mysteries so easily. The vast distances between stars remain formidable, and the barriers of time and space stand as silent guardians of the unknown. But one question looms larger than any other. Are we alone? If life arose on Earth, could it not arise elsewhere? The universe is vast, filled with billions of galaxies, each containing billions of stars and countless planets. Surely among this immeasurable number, life must have taken hold beyond our world. The search for extraterrestrial life has driven human curiosity for generations. Radio telescopes sweep the sky for signals, rovers analyze Martian soil for ancient traces of life, and astronomers scrutinize exoplanets, seeking worlds that might bear resemblance to our own. Yet in all our searching, the silence has been deafening. This is the paradox that bears the name of Enrico Fermi, the Fermi paradox. If intelligent life is common, why have we found no trace of it? The possibilities are many. Perhaps civilizations rise and fall too quickly for their voices to be heard. Perhaps the distances between stars are too great for communication to ever be practical. Or perhaps life is simply far rarer than we imagine. One possibility is that civilizations self-destruct before they ever reach the stars. Technological advancement, while powerful, comes with risks. Nuclear weapons, environmental collapse, artificial intelligence. Each presents a challenge that could spell doom for an unprepared society. The Great Filter, as some call it, may be an unseen force that ensures few, if any, civilizations survive long enough to spread across the cosmos. But there is another possibility. Perhaps intelligence is not an endpoint, but merely a step in an ongoing process. As technology advances, so too does the potential for transformation. A civilization may transcend its biological origins, merging with machines, becoming something beyond what we currently understand as life. Could it be that the cosmos is filled with intelligence, just not in a form we recognize? Perhaps instead of voices, there are networks of artificial minds, hidden in the quiet spaces between the stars, existing on timescales beyond our comprehension. The search continues. Telescopes scan the heavens, satellites drift in the dark, listening, waiting. If there is life beyond Earth, we may yet find it. And if we do, what then? Would we reach out in friendship? Would we learn from those who have walked the path before us? Or would we be forced to confront a truth we are not yet prepared to understand? For now, we remain alone in the darkness, a single spark in the vast ocean of the universe. But in that solitude, there is a kind of beauty, to be aware, to wonder, to seek knowledge. These are rare and precious gifts. And so, as the stars wheel overhead, as galaxies drift in their silent dance, we listen, we dream, and we wait for whatever answers the cosmos may one day provide. The journey is not yet over. The universe has one more story to tell, one of endings and new beginnings, of the fate that awaits the cosmos itself. The final chapter lies ahead, and now we arrive at the final stretch of our journey through time, gazing upon the vast and unknowable future of the universe. It is here in the twilight of existence that the last flickers of cosmic activity play out in slow, inexorable succession. The universe, once ablaze with energy, now begins its long, slow march toward an ultimate fate dictated by the very laws that have governed it from the start. As time stretches endlessly forward, the universe continues to expand. Galaxies drift apart, carried by the relentless pull of dark energy, their light growing ever fainter as the distances between them widen. Already from our vantage point in the far future, many galaxies have vanished beyond the cosmic horizon, their photons stretched to infinity by the accelerating expansion. What was once a grand cosmic tapestry begins to unravel, leaving behind isolated pockets of existence, each adrift in an ever-darkening sea. Within these surviving islands of matter, the dance of the stars continues, but with fewer and fewer partners to take the stage. The grand era of stellar formation, which had persisted for billions of years, gradually winds down. The immense clouds of hydrogen and helium that once fueled new generations of stars are now nearly spent. Only the smallest and slowest burning stars, red dwarfs, remain, their lifespans stretching for trillions of years, flickering softly in the void. But even these, in time, will exhaust their fuel. A red dwarf, after a life far longer than the current age of the universe, will finally fade into a dark, lifeless husk, a black dwarf. This is a theoretical fate, one that no star has yet reached, as the universe is still too young for a single black dwarf to exist. But given enough time, all stars, from the dimmest to the most brilliant, will share this destiny. With the stars gone, the universe enters what physicists call the degenerate era, a time dominated not by bright, shining celestial bodies, but by the remnants they leave behind. White dwarfs, neutron stars, and black holes become the last actors in a dwindling cosmic play. Black holes, with their inescapable gravity, slowly consume the remaining matter, growing larger and more isolated in a universe that has grown impossibly vast. Even the most enduring structures of the cosmos are not immune to the passage of time. At an almost inconceivably distant future, trillions upon trillions of years ahead, black holes themselves begin to fade. Through the slow trickle of Hawking radiation, they evaporate, releasing their mass back into the universe as heat. The most massive of them endure the longest, but in the end, even they succumb, leaving behind only the faintest whispers of their former presence. And so, the universe moves ever onward into the dark era, a time when no stars shine, no planets orbit, and no warmth radiates through the frozen void. The very fabric of the cosmos is left as a thin mist of subatomic particles, drifting endlessly, carrying with them the last echoes of a once vibrant universe. If there is still any form of intelligence in this final age, it would exist in ways we can scarcely comprehend, perhaps as patterns of energy, as the last sparks of entropy wring out the last usable energy from the cosmos. But even this must eventually fade. The inexorable pull of thermodynamics leads to the final state known as heat death, a universe in perfect equilibrium where no more work can be done. Time itself loses all meaning when nothing changes, when no new light is born, when all that remains is the deep, endless silence of eternity. And yet, perhaps this is not truly the end. Some theorists speculate that quantum fluctuations, acting on scales we cannot yet grasp, could eventually give rise to new universes, birthed from the ashes of the old. Perhaps our own cosmos emerged in such a way, arising from the ruins of a universe that came before. If so, then this is not the final chapter, but merely the closing of one book in an infinite cosmic library, its volumes stretching beyond our comprehension. Whatever the fate of the universe may be, one truth remains. We were here for a fleeting moment to witness a part of its grand story. From the chaos of the Big Bang to the intricate wonders of galaxies, stars, and life itself, we have been privileged to gaze upon the cosmos and seek to understand it. And though we are small, though our time is brief, we are a part of this vast and beautiful mystery, forever woven into the fabric of existence. So as you drift into sleep, let your mind wander through the endless corridors of time. Imagine the stars that have yet to be born, the worlds that may one day rise, and the unknown possibilities that lie ahead. The universe is vast, full of questions we may never answer, but in seeking them, we become part of its eternal story. Rest now, traveler, beneath the quiet, infinite sky.